Hi, and welcome to a ramble with me. Today we're rambling about IEB's May 2025 paper 1, question 9. The diagram shows a cone. The sum of the radius and the height of the cone is 30 centimeters. So this could be 10 and 20 or 5 and 25 or half a centimeter and 29.5 centimeters, but the sum of the radius and the height of the cone is 30 centimeters, and this basically gives us a relationship that links the radius and the height. So we are then asked to show that the volume of this cone is given by V is equal to 10 pi r squared minus pi over 3 r cubed. So basically we want to express, so normally the volume of a cone is in terms of the radius and the height, but now they want us to express the volume just in terms of radius, right? So we need to replace the h with an expression that is in terms of r. So we're going to go ahead and use the relationship that we're given. We're told that r plus h is equal to 30. And so if we want to replace the h, we're going to replace it with 30 minus r. So let us go ahead and look at this volume formula, and now we can replace the h with 30 minus r. So we can multiply that in. So we have a third pi r squared times 30 and minus a third pi r squared times r, right? So times by each term in the brackets. And then here we'll have a third of 30 is 10. So we have 10 pi r squared. And the next term will be a third of pi r cubed, which is basically that 10 pi r squared minus pi over 3. Pi over 3 is just the same as a third of pi r cubed. Right. Next up, determine the maximum volume of the cone. So under these constraints, the radius and the height have to add up to 30. What is the biggest that this cone can be? So we would now need to take this expression, this function. So this is our volume function in terms of r, and we want to see where is this at its maximum. So this is a cubic function, right? So if we were to, for example, plot volume versus radius, this is going to be a cubic function that goes like this. I don't know where exactly it is on the Cartesian plane. It could be more this way, more that way, I don't know, right? But because the r cubed term has a negative coefficient, we know that it has this shape as opposed to that shape. And so we're looking for the r that maximizes the volume. So we need to find the first derivative, right? So we have that the volume in terms of r is 10 pi r squared minus, and this was a useful way for them to write it so that we can clearly see the coefficient of r cubed is pi over 3, or a third of pi. So we want the first derivative, which will be 2 times 10 pi and then r, and then over here we're going to say 3 times pi over 3, which will just be pi, and then here we'll have r squared. And to find the turning point, we're going to need to solve where is this first derivative equal to 0. So we're solving the equation 20 pi r minus pi r squared equal to 0. This is a quadratic equation, so you could use your quadratic formula where the coefficient of r squared is negative pi, the coefficient of r is 20 pi, and the constant term is 0. we can also just use our traditional quadratic equation solving methods. So one side is already equal to 0, so we just need to factorize the other side. We can factorize it by taking out a common factor of r. In fact, we can make our lives even simpler and take out a common factor of pi r. So in the first term, we're just left with 20. In the second term, we're just left with r. So pi is just a constant, so that's a non-matter, right? So either r is equal to 0 or r, well, or 20 minus r is equal to 0, which would mean that r is 20. But now we can't have a cone where the radius is 0, so this solution is invalid. Also, I just want to modify my graph to reflect current affairs. So the graph looks something like that actually. Right, so let me just shrink this because I don't feel like creating a new page. Oh! Right, so invalid because r has to be greater than 0, and so therefore this is our solution. Well, this is where the volume is maximized, when r is equal to 20. We can also check this by, and I'll do this in a different color. We can check whether the maximum occurs here by finding the second derivative. So in this case, our second derivative will be 20 pi minus, and this term will become 2 pi r. Okay, and then we want to see when r is equal to 20, what is the value of the second derivative? So it will be 20 pi minus 2 pi, whoa, space, 2 pi 20, and that will be 20 pi minus 40 pi, which will be a negative 20 pi, and that will be a negative number, right? And what does that tell us? So that then tells us that when r is equal to 20, the graph is concave down, meaning that when r is equal to 20, we have a local maximum. So that would be another way that we can determine that this is where our maximum occurs. And if you were to put r is equal to 0 into the second derivative, you would have 20 pi minus 2 pi 0, so this term would disappear. So you would just be left with 20 pi, which is positive, which would tell you that at this point the graph is concave up. So then r is equal to 0 is a local minimum. And we are looking for the biggest r, well, the r that will give us the biggest volume, rather. So, yeah, so this would be incorrect. We don't want this, we want this. Okay, and so therefore, so therefore, when r is equal to 20, v has a local max. Right, and so let's work out what this maximum v is equal to whatever the value of the volume is when r is equal to 20. So we can put that in here. Okay, just need to shrink this again. Right, so this is 10 pi 20 squared minus pi over 3 20 cubed, which I'm just going to put into the calculator. Right, so this is roughly 4,188,79. 4,188, comma, yay, space is running out here. Once again, oh, should have just added another page, honestly. All the stress. So this is 4188,79 cubic centimeters. Right. So next question. The graph represents the function f of x is equal to 10 pi x squared minus pi over 3x cubed. So this is the volume function that we found here, except our r's are now being called x's and our function is called f instead of v. Right, and we see that it is like what I sketched here. Right, we're asked to give the coordinates of m, right, which is a turning point, and n is an x-intercept. Okay, so coordinates of m, we already know that the x coordinate is 20, and then the y coordinate is the volume that we found, the volume value, which is 4188. Oh my golly wolly. 41. Oh, I'm lying. Whoa. What? No, I'm not lying. 4188,79. Now, what I'm very curious about is whether they are going to give, I mean, yeah, this is where mark allocation would be nice. But anyway, you save yourself a bit of time if you recognize that this is the same function we were working with in the previous question. And so we already know the coordinates of m. We know that the local max occurs when x is equal to 20, and this is what the function outputs when you put x is equal to 20 into it. Right. So, next question. Calculate the values of a and b if the equation of the tangent to f at n is given as y is equal to a pi x plus b pi. So we want to find the equation of the tangent to the x-intercept over here. Whoa, 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 whoa. Oh, what is happening in the world? Right, let's try that again. Okay, so that is a terrible tangent, but anyway. We want to find the equation of that pink line. So first of all, we need to figure out where the x-intercept occurs. Then we need to find the gradient of the curve at that point, and then that will give us the gradient of the tangent. And then we can sub in the coordinates of n to find, yeah, the last bit of the equation of the tangent. So let's find out the coordinates of n. So let's write down what our steps are going to be. Determine coordinates of n, and we're going to do that by solving where is f of x equal to 0. Right, so 10 pi x squared minus pi over 3 x cubed equal to 0. So I'm going to factor out the common pi x squared, and I'm going to be left with 10 here, and here I'll be left with a third of x. Right, so then either x squared is equal to 0 or 10 minus a third x is equal to 0. And from this first one we have x is equal to 0, which would be that x-intercept, or minus a third x is equal to minus 10, and so x will be equal to minus 10 times minus 3 if we times by minus 3 on both sides, So that'll be 30. Right. So now we know that our x-intercept occurs. Oh, why is that word so hard to say? Occurs. Occurs when x is equal to. Yes, nothing is cooperating. Right, occurs when x. Hi, what did I leave behind? Yo, guys, what? It's none. Okay, let's hope now I got everything. Okay. Next. I don't think I need that anymore. You can come here. Okay, not bad. Right, so we found our x-intercept. Next up, we want to find what is the gradient of the curve when x is equal to 30. So, gradient, yeah, I should stop writing in weird places. I must write in places where it's easy for me to grab everything. Gradient of f when x is equal to 30. Right, so we already know from the previous question that the first derivative is something that I've forgotten. So over here it was 20 pi r minus pi r squared. So that'll be 20 pi x, I've already forgotten, minus pi x squared. Okay, so let's figure out the value of the gradient when x is equal to 30. So that will be 20 pi 30 minus pi 30 squared, which you can work out on your calculator. That is absolutely no crime. So I think we should get negative 300 pi. Right, so that is the value of the gradient when x is equal to 30. Good. Next up, so that tells us that the equation of the tangent is something like y is equal to minus 300 pi x plus b pi. Okay, so we don't know what the b pi bit is yet. In order to find the b pi bit, we're going to sub in the point n, which lies on the tangent as well. So we know that when x is equal to 30, the y coordinate is equal to 0. What am I doing? Why are we recording voice? What was that? Oh my heavens, I hope that did not interfere with the video. Anyway, so that will now be minus 9,000 pi plus b pi is equal to 0. Okay, again, forcing matters, refusing to go to a new page for reasons unknown to mankind. So b pi will be equal to 9,000 pi, meaning that b is equal to 9,000. Right, so we were asked to find the values of a and b. So we now know that the equation of the tangent is given by y is equal to minus 300 pi x plus 9,000 pi. So this is now in the form that was required of us. A pi x plus b pi. So that means that a is negative 300 and B is 9,000. Let's have a look at the memo. Question 9. Right. So first part of the question, we pretty much did, yeah, nothing much to say there. Next question, we got we disqualified one of our solutions, and then we went with R is equal to 20, and then we got our volume value to be 4,188.79. Yeah. And then the next one, yep, no calculations required there, just using the information from the previous question. The coordinates of M are 20 and 4,188.79. And then the last question, right, we found our x-intercepts. We put it into our first derivative for f, and then we put that into our tangent equation. We sub in the point n, and we get a is equal to negative 300 and b is equal to 9,000. So all in agreement there. And as usual, I hope that this was a good and fun exercise, and yeah, chat again another time.